So now what we've got is 3.6. In section 3.6, we're solving systems now in 3 dimensions. One of the things that we used to do that we don't do anymore is we actually used to plot and graph. See, this will load up here. We used to plot and graph in 3 dimensions. Now, what I want you just to visualize, what I want you to see here is that I didn't see it. When we would plot in 3 dimensions, you'd have, what I want you to see here is your x's go forward and back, y's now go left and right, z's go up and down. We no longer really do this because it's not a big skill that most students really need to assess or be able to possess it all anymore. But what you would have to do is you'd walk out, you'd plot here, and you'd walk up. So it'd be this weird process to plot something in 3 dimensions. But what this basically is showing is that where do 3 planes intersect? For example, if you look at the corner back there, you've got the window wall, the back wall, and the ceiling. They all intersect at the one spot. That's what happens here. You've got 3 things going 3 directions that intersect in one space. So that's where we come up with solving systems in 3 dimensions. Basically, it boils down to doing the following. Working with 3 equations, with 3 variables, and then using some form of linear combination and or substitutions to solve for all 3 variables. Now, when we set these types of problems up, we set these things up, and I'll let you guys write this up here. Most students don't have any issues with the arithmetic. This is very, very similar to what we did back in section 3.2 when we solved systems with just 2 variables and 2 equations. You're going to use the same skills, same skill set, same process, same everything, same thinking on it, but there's just an extra line and an extra variable. Okay? One mistake that most people will do, copy the problem down wrong, or you'll forget a sign. A sign. Oh. Instead of if you multiply something out, you'll forget to bring a negative along. I'm going to do my best to make sure that the problems that you guys get all have regular boring integers for answers instead of ones that have fractional amounts, because I don't want you to freak out when you see a fraction, because I mean it can happen. But the ones that we're going to get, especially for tonight, should all work out nice and clean. So we start these problems kind of the exact same way as we did before. Remember when we did 2 variables, 2 equations, we'd always look for that alternating sign, because if you had the same coefficient with opposite signs, we would just add the 2 equations together. Remember that? Wow. Or we would try to figure out which one was the easiest to get, or that had a variable or with a coefficient of 1 and try to do some linear combination with that. We kind of use the same thought process here, and we use one equation to eliminate a variable in the other 2. For example, in this case here, do you see a variable that has a negative symbol and a coefficient of 1? Yes. Where? Negative y in that second equation. So if I take that negative value, negative 1y in the second equation, by a linear combination method, if I multiply the second equation by 2, and I add it to the first equation, will the y values drop out? Yes. Okay, let's do that. Let's take the second equation, multiply it by 2, and we're going to add to that to the first equation. So we have 3x plus 2y plus 4z is 11. And to that, I'm going to rewrite the second equation. 4x minus 2y plus 6z is 8. Yes? Do you see how you have a negative variable here?
Yeah.
If I multiply that by 2 and I add the top and the middle one together, will the y's go away? I'm trying to eliminate, my goal here is to eliminate one variable from both equations, and then I have a problem that we've done before with 2 variables. Okay? So from here you wind up then, when you add them together, 7x 10z is 19. Do you agree? Now, if I want to eliminate the y value in the third equation, what do I multiply the second equation by now? 3. So I'll rewrite the third equation. 5x minus 3y plus 5z is -1. Now I multiply this guy by 3. And I get the following. 6x minus 3y plus 9z is 12. Do you guys agree? Now I have same coefficients, the same signs. What do we do? Subtract. Good. Now I'm going to put the subtraction symbol all the way across. And the reason that I do that is because I don't forget to subtract each of the 4 pieces. We have 4 subtraction problems now. 5 minus 6. Bless you. This one drops. 5 minus 9. And then -1 minus 12. So far, so good? All right. So now you have 2 equations with only 2 variables. 7x plus 10z is 19, and -x minus 4z is -13. Now, how do you get rid of one of those variables? Yeah, multiply the bottom one by 7. Do you guys agree? Okay. So multiply the bottom one by 7. I'm just going to rewrite the whole thing right below here. So I have 7x plus 10z. So now I have -7x minus 28z is -91, I believe. Taking that with a leap of faith. Way to go. Same coefficients, opposite signs. What do you do? It is. I add them together. Like I said, you run out of space real fast on these problems. You know what? -18z is no, it's what? It's adding.
So it's 110.
No. 72, -72. Use your calculator. Where is your calculator?
I got the answer.
What's -72 divided by -18?
4, according to my calculator.
So now you are 1/3 of the way done. Well, you have x, y, and z. You solve for z. You have 2 more to go. The rest of them are easy. So now you know what z is. Z is 4.
So basically now it's just back to your...
Correct. And now you just go back and resubstitute in to solve for the other ones. So if z is 4, that means that 7x plus 10 times 4 is 19. So 7x becomes -21. 19 minus 40. X is -3. And then once again, you got to go back to find y. And it does not matter which one you choose to go back to find y. Really doesn't make a difference. 3x, 2y, 4z.
Just take the z and insert it into the equation and
Yep.
solve for another variable.
Yep. You just keep on moving down the line. So here you have -9 plus 8 is -1. Add that over, you get 4y is 12.
Wait, what equation did you substitute
Yeah.
into?
I just picked the top one. It doesn't matter which one you choose.
Yeah.
Wait, x is -3, right? So you can do any equation
Yep.
on the board and substitute in any of them.
Yeah, because this solution set, this solution triple, if you will, makes all three of these a true statement.
Alright.
So 3x, 2y, 4z.
Why the I'm just writing the first.
Yeah, I had these, excuse me, I had those backwards there. 3x, 2y, and 4z. So, excuse me, negative 9 and 16 is,
Seven.
No, it's 7.
Seven.
bring that over, 2y is 4.
16 minus half.
Divided by 2, which is 2.
Okay. So now, your final result, instead of being an ordered pair, it is an ordered triple. Negative 3, 2, and 4. Like I said, the arithmetic here isn't going to be all that difficult.
It's just very tedious.
It's tedious. And you see how I made that mistake by flipping my numbers around by mistake?
Yeah.
That's about as dumb a mistake you're going to make. Okay? No. You can't graph them. Technically. You have to get a hammer. What's that? Yeah, there's a fourth. We can do a fourth one if you want. A 4 by 4?
4 dimensions?
Yeah.
I'm not.
It's the third dimension turned inside out.
So how do you do that? How would that look?
Yeah, show me that one.
If you have
Just put another variable out here, another equation.
something three-dimensional.
How do you graph?
inside.
Yeah, how do you graph?
I don't know. I didn't go to that class. Yes, sir.
When you substituted x into the equation 7x plus 10 equals 19, you know that? You know what you did? Could you do that to like any equation?
Yeah, you could have done that to this one also, because you already have it in terms of x and z. So if you know what z is, you could have put it here as well. You're going to get the same
so it's just
value.
something that-
Yeah, it doesn't matter which one you choose there. Yes, sir. Yeah. Yeah, because what's going to happen is once you find one of the variables, you probably have an equation right above it with that variable and one other, and you just keep working your way back up. That's all. You just work your way back up. The algebra isn't difficult. It just takes forever.
You have to practice problems. So wait, do we?
You have to go to the internet.
Take a whole page.
You plug that into your computer, but you have to get the program download it.
We don't have to do that. You program it off of the internet?
Yeah, can you like program it like school?
I don't know.
Some of these calculators have more apps on it.
There's only a couple of apps that you'll even use, and when we need them, I'll give them to you.
Derek, please don't like my
It's one of the algebra 1C.
Gentlemen, come on. Stop trying to stab each other.
It's having fun.
Yeah, really?
So what happens again, you get into a problem, you have 3 variables, 3 equations, and it is up to you to decide which one do you want to try to eliminate out of the other 2. My suggestion, work with variables that have coefficients of 1, and try to find ones that have alternating signs. Soda was doing some weird dance. What were you dancing? What were you miming, I should say? It can go either way. It doesn't matter. Yeah. When you rewrite these things out, it doesn't matter where you put them. As long as you're multiplying out by the right scale, you're going to be fine. Does everybody see how the first equation has a negative z and the other 2 have positive values of z? Let's use that first equation to eliminate z in the other 2. Okay? So one of them is going to be a little bit easier to get rid of than the other. If I just take the first equation and add it to the third equation, if I just add those 2 together, z goes away. Do you agree?
Yes, sir.
All right, let's just do that. So you have 3x, 9y, and 36. You agree?
Yeah.
Let's do the same idea and eliminate z again in the second equation. To eliminate z in the second equation, what do you have to multiply the first equation by?
2.
2. I see scrunchy face. Are you okay?
Katie's never nice.
It's not me.
So
Not
if I multiply the first equation by 2, I get 2x plus 10y minus 2z is 32. Below that I have 3x minus 3y plus 2z is 12. So when I add those guys together, we get 5x, 7y, and a 44.
What do you do after that?
What do I do after that? I cry.
That's what I'm doing right now.
Because right now I have the following two equations. 3x plus 9y equals 36, and 5x plus 7y is 44. Now you use linear combination substitution again to solve it. But wait! Look at that first equation, 3, 9, 36. What can I do with all of it?
divided by 3.
Divide this whole thing by 3, and you get x plus 3y is 12. Do you agree? Yes, sir.
Yeah. So, all right. So you have to find the equation to the one to the right first, and then you have to go back and find the equation to the one to the left. So you have to do both those equations. to find the
Yeah.
answer.
What you're doing here is when you first start the problem, you want to eliminate one variable. Use one equation to eliminate that same variable in the other two.
Okay. Okay.
All right. Now you're at two variables, two equations, which we've done, and I'm setting this up to use substitution because I know that x is 12 minus 3y. Now, could you have done a linear combination with the 3, 9, and 36, 5, 7, and 44? You know, multiply the top by 5, the bottom by 3, and subtract? Absolutely. There's no rule that says you can't. You can do whatever method you feel more comfortable doing. Me, I think it's a little easier when I see something that has coefficients in common, you know, they all have the same multiplier, to set it up a little bit quicker. So if I know that x is 12 minus 3y, then I can say that 5 times 12 minus 3y plus 7y is 44. So I have 60 minus 15y plus 7y is 44. I'm going to add the 8y to the right, subtract the 44. I get 16 is 8y, and y is 2. And once again, I've already solved for the y. Now I know that x is going to be 12 minus 3 times 2, which is 6. And now I know what x and y are, so I go back up and I solve for z. 2x plus 4y plus z is 20. 12 and 8 is how much? That's 20 minus 20. So you're ordered triple. 6, 2, 0.
Did you get 2 for y?
I did.
Cool.
All right. See, it's not that. I mean, it's not that bad. It just takes a little bit of time to get used to it. All right.
Me?
Shay, you okay? Okay.
All right. So what do you do after you get the 2? The 2 equals y.
Then what I did, whistling. What I did is I knew that y was 2. Over here, see how I had x was equal to 12 minus 3y? Got x, went back to get z.
Okay. All right. Okay.
It's a lot of substitution and going back and forth. It's just lots and lots of substitution. Now, think about the other two things that we did have happen when we had systems of equations with 2. Remember, we also had stuff that was no solution. We also had stuff that was infinite solutions. Do you remember what it looked like if it was no solution? What would that look like as a result? That's
Everything
infinite.
out.
If they're parallel. Right?
If they're parallel, yeah. So remember, you can have no solution. Now, in this case, since we're three-dimensional, it's a little bit not so much parallel here. But remember, a lot of times you might see this. If you get this, is that a true or a false statement? It's no solution if you get a false statement, but it's an infinite solution if you get something like this. A true statement. Okay?
I think of a chip, a Pringles chip, every time now.
I know.
At least I taught you something.
And they chose them for slow.
When he chose them for slope, exactly. So I've got two things going for me.
Because they went through the whole alphabet. And got to M.
Okay? Say what? No, it's joint variation. All right. Try this one.
I'm still.
Wait, I still want to pull out.
Into this one here. I know. I figured. I'm assuming most people saw the negative z in the first equation. And you're probably trying to eliminate z in the other two, correct?
Right.
Why wouldn't you do that?
Wait, I'm supposed to eliminate Z?
No, you can, guys, you can eliminate whatever you want. All I'm saying is, if you start with, you see alternating signs, just go with that one. This one has a coefficient of 1. Make your life easier.
No, I was very close to that.
Where did you start with?
So, I'm going to eliminate z.
Sweet.
I'm going to take the second equation, and to that, I'm going to add to it 2 times the first. 18x, 10y, minus 2z is negative 22.
Did you get x equals 0?
So by doing that, I multiply the top equation by 2. I'm adding it to the second equation, and I have 24x, 14y is negative 20. I do the exact same idea. I take the third equation, 2x minus 2y plus 4z. To that, I'm going to add to it 4 times the first. I'm once again eliminating the z value. Yes, sir?
So since you multiplied the top one by 2, you have to use that. You have to modify that one to solve for the other two.
It's the easiest way to do it. You will get less locks if you do that. Okay? So by eliminating that, I have 38x, 18y is negative 40.
I can't just simplify that.
You can if you want. At this point, you have 2 equations with 2 variables. It does not matter which one you try to eliminate at this point. You can simplify it if you want to try to get into the numbers a little bit easier to work with. It does not matter because you guys all have calculators. Just multiply the top one by 18, the bottom one by 14, and then subtract them, and then all of a sudden your y values are gone. Okay?
Why?
Huh?
Where did the 14y come from?
4 times 0.
Remember, I'm using this first equation. I multiplied it by 2, and I add it to the second equation. I multiplied it by 4, and I added it to the third equation. I'm using the same equation to eliminate a variable in the other two. Again, I'll multiply the top one by this, the bottom one by that.
And why again?
Just make my life easy.
So you got X. And then you just substitute that in. What'd you get X? 0?
All two. Alright.
That's the fridge, man.
What'd you get?
I know that the y, I know that the y values will be eliminated when I subtract out, so I just subtract.
Wait, isn't 360 -2 because it's -20?
Thank you. So I get negative 100, x is 200. And x is negative 2. It's not bad, it just takes forever.
Yeah.
Now, if x is negative 2, you just substitute back in. So 24 times negative 2 plus 14y is negative 20. That's negative 48. Add that over. We get 28, so you get 14y is 28. So y is 2.
So you can leave Z out of the whole thing until you solve for X and Y?
Yep, because you,
can just throw in one
Yep.
of the equations?
Yep.
Perfect.
So 2x minus 2y. 2 times negative 2 minus 2 times 2 plus 4 times z is 4. Negative 4 minus 4 is negative 8. 4z is 12. Z is 3. So your ordered triple. Negative 2.
So
2.
Murphy, is this something that we really need to study into or just understand that's going to take a long time?
Just gonna take a long time.
Okay, it's basic.
Fairly basic. We're not going to worry about it. Everybody does graphing a little bit differently. This book goes, X is going towards you, Y's go left and right, Z's are up and down. I'm not worried about it. So what I want you to try tonight, I've got 5 of these. Flash. On the page. Now, remember, the last 2 on here are a word problem. There are 2 word problems. One of them gives you a table about price per pound. You're trying to figure out how much the thing costs per pound. That does have some fractions in it for fractional variable coefficients. They're not that scary. Leave them as fractions, and you'll see that they'll eliminate themselves out rather easily. Number 35, you have to figure out the word problem is a little bit trickier because you might not use all variables for one of the equations. But the other 3 are straightforward, like the examples we did in class. Your numbers should work out cleanly. Okay? Obviously, the word problems are going to be a little bit different, but the first 3 should be clean. Yes, sir.
Is the website for the textbook back up on your?
It should have been. I was surprised that you guys said it wasn't working the other day. Has anybody got their phone out? Would you check to see if the 3.6 is working?
The link going to